All right, today we're going to be talking about factoring linear expressions. So, you guys have heard of the word factor before when you've talked about things like prime factorization and greatest common factor. So, when you factor a number, it means that you're writing it as a product. Oh, looks like I need to make that a little thinner, of its factors. Let's make that a little bit smaller and another color. All right, so the same is true when you are talking about monomials. Monomials are like one term in an expression. So mono means one, and it just means that you have one term, not more than one that you're adding together. So let's talk about greatest common factor. When we're finding the greatest common factor of two monomials, first we are going to find all of the factors of the coefficients. So if we start with this first term, we'll do 2 times 2. Those are the factors of 4. And then we're just going to put the variables next to it that we have in that term. For 12, the prime factorization of 12 is 2, 2, and 3. And you might be thinking, I don't remember how to find the prime factors of a number, so let me remind you about the factor tree that you learned in elementary school. You pick 2 numbers that go into 12 evenly, let's say 2 and 6, and then 2 and 3 go into 6, and the prime factorization is the bottom of each of these like roots. So that's where I got the 2, and the 3 from this prime factorization. And if you don't know the prime factorization of a number, you can just make a factor tree over on the side, it's no problem. And then after you write the prime factorization, you're also going to include the variable, any and all variables that you have after the coefficient. All right, so to find the prime factorization, so the whole point of that was to find the prime factorization, oh my goodness, not the prime factorization, the greatest common factor. What's going on? I thought I was erasing. Where the directions say to find the greatest common factor of each pair of monomials. So for finding the greatest common factor of 4xy and 12x, we're going to circle what they have in common. They have a pair of 2's, another pair of 2's, and an x. So the greatest common factor is 2 times 2 times x, or just 4x. All right, let's do number 2. Number 2, the greatest common factor of 42mn and 14mn, we're going to be able to find by finding the GCF of each of those terms. So if you're not sure what it is for 42, you can go like this. 2 goes into 42 21 times, and then you can do a 3 and a 7. And then once all of the numbers here at the bottom are prime numbers, which means that the only factors they have are 1 and itself, then you know you've done the prime factorization for that number. So 2 times 3 times 7, and an m and an n. For 14, I know we can just do 2 and 7, because 2 and 7 are prime numbers, so that's the prime factorization, and then they each have an m and an n. Now I'm going to circle what they have in common. They have a pair of 2's, a pair of 7's, a pair of m's, a pair of n's. So 2, 7, m, and n, or 14mn. Alrighty, so you might not have to go through such a long, detailed process to find the greatest common factor of 2 terms like that. You might just be able to look at it and say to yourself, oh, I know that 14 is the biggest number that goes into these 2 evenly, and I know that 4 is the biggest number that goes into these 2 coefficients evenly, and then you just use the variables they have in common. That's totally fine. So that's how you find the GCF. Now we're going to completely factor expressions. Factoring an expression is basically doing the opposite of the distributive property, or like backwards distributive property, sometimes you'll hear me say. So first we're going to find, if we're going to factor these expressions, we're going to find the greatest common factor of 36x and 24. So what's the biggest number that goes into 36 and 24 evenly? It's 12. And then do they share any variables? In this case, no. So we're going to write the greatest common factor outside the parentheses, and inside we're going to write whatever we would need to multiply that 12 by to get each term. So to get 36, we'd have to multiply 12 times 3, and to get 36x, we'd have to multiply 12 times 3x. And then to get the 24, we'd have to multiply 12 times 2 to get the 24. So that's how we factor that expression. Now, if we wanted to check our work, if you do 12 times 3x, like distributing, right? And if you do 12 times 2, you get 24, and we end up back up here where we started from. So I'm positive I did it right. So my answer is this, though. It's like the backwards of distributing. So let's try another one. We're going to find the biggest number that goes into 175 evenly, which is 25. And then any variables they share an x and they share a y. And parentheses will be whatever I'd have to multiply 25xy by. To get 100xy, I'd have to multiply it by 4, because 25 times 4 is 100. And then we already have an x and a y, so I don't have to put a variable after the 4. Since this is subtracting, then I'd have to multiply 25xy by a 3. 25 times 3 gives, sorry, dog is jumping on my lap. 25 times 3 is 75. We already have an x, we already have a y, but we're also going to need a z here. And if you're unsure if you've done that correctly, go ahead and distribute and see if you wind up with the original expression. Alrighty, for this one, the biggest number that goes into 14 and 12 evenly, I think, is a 2, and they share a y. I'd have to multiply 2y by 7x in order to get 14xy, and I'd have to multiply 2y times 6 to get 12y. And lastly, let me show you something here. If we think by looking at 81 and 18, that probably 9 is the biggest number to go into it evenly, and they share an a and a c. I would need a 9, because 9 times 9 is 81, and I'd need a b, so that AC times b is ABC. And then 9 goes into 18 twice, and it already has the a and the c, so we'd be done. And again, if you're not sure if you did it correctly, just distribute. 9 times 9 is 81. AC times B is ABC. And then 9AC times -2 is -18 AC. So we're sure we got it right, and that's the answer. One thing I did want to say is if you ever find inside parentheses that the terms still have a common factor, then you know you didn't pull out the greatest common factor here. Like, just as a side note, I want to show you an example of what that would look like. For number 1, let's say you looked at that and you thought, oh, I know what goes into that evenly, 6. And you didn't know that, you didn't realize it was 12. You thought like 6 is the biggest number that goes into 36 and 24. So let's say you took out a 6. You would have to multiply 6 times 6x to get the 36. And you'd multiply 6 times 4 to get the 24. So when you look inside the parentheses here, if these numbers, these terms have a common factor, in this case 2, then that means that the number you put in front of parentheses was a common factor, but not the greatest common factor. It means you could have taken out something bigger, which is your goal when you're factoring expressions. Alrighty, that's it. Thanks for watching, guys.